So I'm Carlo Marobbio and I'm from University of Bari, Italy. And I've been working for Ataxia about 8 years ago. And we use this drug, which is called Diazoxide, which is a drug normally used for the hypertension therapy. And we found that this drug, which is an activator of a potassium channel, is able to induce the frataxin expression. And we test this drug on 3 cellular lines from frataxic patients, and with 3 different degrees of severity. And we found that this drug is able to induce the frataxin protein. And we also test this drug on mouse model. We collaborate with Mark Pook, and we test this drug with a humanized mouse model of Mark Pook, and we found an increase of frataxin in mouse tissues, especially in cerebellum, brain, and heart. We also found an increase of aconitase activity, which is a mitochondrial enzyme which is damaged in the Friedreich Ataxia. And we found an increase which is statistically significant in the brain. And also we found a decrease of oxidative stress in mitochondrial proteins, and especially in brain and pancreas and liver. So Mark performed the functional study with a mouse model, and he found improve of coordination abilities of the mouse, in particular time to take the cross beam and the stride length of the mouse. And we found a slight decrease of locomotor activity, but we have to investigate this behavior. So we update this work by studying the molecular mechanism of the diazoxide. And we found that diazoxide is able to induce the mTOR pathway, which is a cellular pathway involved in cellular proliferation. So when we use the rapamycin, which is a specific inhibitor of the mTOR pathway, we cannot observe the increase of diazoxide when diazoxide and rapamycin are put together in the cell. So probably this process involved this pathway. Also, we observe a nuclear translocation of NRF2, which is a transcriptional activator of antioxidant pathway, and Cortopassi found that NRF2 are able to induce the frataxin expression. So probably the mechanism is that diazoxide induces mTOR kinesis, and this induction promotes the NRF2 nuclear translocation, which is involved in frataxin induction. Also, we test the toxicity of diazoxide in 3 different cell lines, and we used 100 micromolar, which is not toxic for ataxic cells. So for the future, we like to contact some hospital to start a small proof of principle with a small number of patients to test the effect of the diazoxide in the patients.